Hey, what's up, guys? So, uh, today I'm going to tell you about the DP problem. Okay, so if you are not falling in love with the DP, uh, first of all, if you are not introduced with DP, dynamic programming, so don't worry. You also go with my this video. You definitely think that concept DP is not a what DP is not a theorem or anything else. DP is just a concept. So you definitely go with this video if you are not familiar with DP and what DP is just a concept. How we think with the array and how we implement how we think with the array and how we implement with. Yeah, I know you have little bit problem if you are not familiar, but it's okay. And if you're familiar and you are not fall in love with DP um, for any reason, so you definitely check this video. Um, I tell you a problem which you'll love with this DP. So without any further delay, so it's a very famous Leetcode problem. Actually, this problem is asked by an interviewer uh, in my interview. At that time, I'm not able to solve it because I also afraid with DP. But today, I will definitely tell you the approach, the code, everything. So please check it out. If you are not falling in love with DP, please. And if the video is helping you, then please share it and also give the like. So let me share my screen as usual. Um, I think I have to share the my entire screen. And also let me. Where is this? Uh, how can we? So I'll. So this is guys. This is famous lit code problem. I don't know why I'm looking so small, but it's okay. Uh, you consider it here. So let me open my what uh what you say, I don't know. Paint tablet. It's done. Okay. So yeah. So let me first go with this. Okay, where is yeah. So first thing, what problem is asking us? What problem telling us? Sorry, asking no. So there is a robot on M and N grid. Okay, it's fine. And here is the robot. Okay, it's in the top left corner. Okay, it's not pro. It's always in the 0 by 0 starting position. Okay, that's fine. No worry. So what now? The next line is very important. Please read it carefully. The robot tries to move bottom left corner, that is m minus 1 and minus 1. I means this position, row minus 1 and column minus 1. So our last grid, yeah, our last grid of that matrix. Okay. So robot can move only either down or right. So noted this point. It's either move right or down. Uh, n- uh, and also there is no condition that it's move only one step, two step, three step. Either it can move here and here. It's the question requirement and how we approach. It's totally depend on us. Nothing is given by the question. So let's proceed. So yeah, then how can we proceed this? So let's take some example. So the examples are so big. So I go with the smallest examples. So let's suppose 2 by 2 matrix. Okay. So here my is robot and there is star. So how many paths are required for this position? So if I want to visit here, I will move one. So one. If I move here, one, one. And if I want to move this position, this star position, so first one, two, because first right, then down, because this is the condition where it is. Uh, I'll tell you now, please note it down, right and down, okay? And for this position also this path is required. One, two. So how much? Two. So total how much? Uh, uh, I guess I think yeah. Total. Uh, 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 I've done some mistake. Mm, um, um, no, because one. Okay, okay, okay. Yeah, yeah, fine, fine. It's fine. One and two. So two plus one. So total how many paths are? Hmm. I guess maximum path for the start because I have to confirm this example first. Let me go with this example. So M is 3. Okay. Let me first clear my old drawing. Okay. So M is 3. I mean, row is 3. Okay. This is 2 only. This is 3. Okay. 1, 2, 3. Take it like my drawing is so good. That's why you are. And here's my star. So for this position, 1, 1, 1, 1. Because I have to go with like this. And oh, sorry, sorry, sorry. What is happening here? One, one, two, three, and two. Sorry. So here's my robot. So one, one. Because for down there is no condition. You have to just move one step, or I have to move any step. For this one, one. And for this, one, two, one, two. So two. One path, two path. Okay. And similarly for this, mm, for this, 1 plus 2, uh, okay, for this 2 and 3 and hmm, okay. So, how is 3 now? You are worried about. So, first I go like 1, 2, okay, no problem. One path this, one path this, and one path. Hmm. First I go here and then move here. So, 1, sorry, 1, 2, 3. So let me assume like this. Here is a robot. You go first 1, then 2, and then again 1. So 1, 1, 1, 3. Okay. Similarly like this. 1. Mm, yeah, total path we have to assume. 1, 1, and the unique path is yeah, right, down, down, right. Because it's the same thing now. Either we go from here for this path or this path. I think it's similar. That's why answer is 3. So let's see how. the explanation tell us, because I am not going to this point, because I have to assume through that direction. That's right. So write down down. Okay, right. Oh, wait, right. Okay, write down down. Okay, yeah, 1 point. Down down. Okay, down down. Wait, is down down. Down down right. Okay, down down right. Hmm. And down right down. Yeah. Okay, okay, yeah. That's why. Yeah, it's fine. We are getting our three paths. So it's just like that. So let me tell you the code point of view. So let's see, here's our robot. So for this one, 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 for this one. Why one? Because either you move for one step or one, because there is no condition. Na? You have to move one step at a time. We can move directly here. So for each and every grid, we are required only one, one time, or one path. Yeah, just straight line, right? For this one, because we just line down and robot can move right and down, so it's fine. So now this, for this point, why I'm writing two? Because either he moves right, down, down, right. So that's why two. So similarly, we are required this kind of some coding complexity. That's always remember it's what, previous point and previous column point. I mean previous row point and previous column. I think you are able to understand what I am saying. So suppose you are here. So either you are required your this position, either not, you are required your this position and this position always. So it's very easy now. If you are suppose I and J, so what will this position? I, sorry, yeah, I minus one J. No, no, no. Why? Uh, um, I guess not this position. Oh, sorry. To always confirm. Okay. So if you are here, suppose I J you're here. Suppose you are any point of your matrix. Okay. So you are required this position and this position. So what is this position? This is I minus one and J. And what is this position? I and J minus one. So after adding this position, you are able to see this position. So it's very true now. Why not go with this line of code? So what my approach is, I just fill this and this with one. Actually not fill this and this only. I filled whole array with one, and I start my position from here. And I always keep a pointer for these two and always add up to this value. After adding, I finally got this point and I return this uh, matrix value. So it's give me the unique path. So now I guess I tell you many things. So first let me code it, and you are definitely I am certain you are love this problem, because now you are definitely love this problem. So let me minimize it and also clear the drawing. So let's see what I am telling you. So let dp is equals to, okay. uh, Array dot fill, not like this. So we are required 2D array. Why? Because we are dealing with 2D things. That's why. but it's not the correct answer. I am telling you. Because if I going with the concept, then it's very lengthy video. But no worry, the concept is main important. Because why is 2D array? Because if you are assuming or what, if you are what if you are clearly see it, then our two variables are changes always, row and column. Is it now? Because every time the row value and the column that particular but position changes, means position value changes. Because initially if I fill with 1 1 1 1, then row and column changes. That's why two variable changes. That's why using dp of 2D. If one variable is changes, then what d required. That's a concept behind it. If you're not familiar, then just go with the code. Don't worry, you will get this. So what array dot fill? Um, so first let me with the row of that what why not uh, okay, and array dot fill with an no, sorry. So this is my row and this is my column, and I will fill this with one. Why one? Why one? If you are familiar with DP, then many teachers fill with minus infinity zero sometimes. So it's totally requirement of our question. Because I feel one, because I already get my this row and this column filled with one. So I need this. So I am not filled with one. So now let for loop row is equals to 0, not 0 1, because I'll tell you why. Row is less than m. What is this? There is a thing which is okay. And row plus plus. Okay. Let call one less than n call plus plus. Yeah, fine. So now dp of row call is equals to now I'll tell you now that position. So just move the dp of row minus one call plus dp of row call minus one. So yeah, we are done. Return dp of m minus n and minus 1. Finish. Khatam. So we got our answer. That's a code. I will tell you now, you fall in love with DP. So that's a simple approach. We are always what we are always tracking that our previous value and uh, one step what one decreasing row value. Always track your previous position and TP. Yeah, and this is tabular form. For the people who are familiar, I'll tell you you are familiar. So yeah, now submit. beats 108. Nobody. So that's a simple code of TP. Nothing. Yeah, TP codes are very small and quite hard to understand. Yeah. So that's it from this video. I hope you liked it. If you liked it, then give a subscribe, like, whatever you want. And also, if you are uh, thinking that I'm not able to answer that one, then please ping comment below so I can definitely um, do a short video for that and you are able to understand. So yeah, let me stop my sharing. So for this, for today now only, and I hope you are able to understand. Yeah. So give a like. With a virtual background, I'm not able to see the live, and subscribe whatever uh, there. Please give me that. Okay, bye.